Welcome to the next chapter of the Modular Monolith Architecture course. In this chapter, we will be talking about authentication and authorization. Authentication is a way for us to figure out who is the current user trying to access our application. Authorization is a way for us to manage what the currently authenticated user can do. Now, let's take a quick look at what we are going to cover in this chapter. First, we will introduce a new component into our system. This will be an external identity provider called Keycloak, and we're going to set up Keycloak from scratch in the next lesson. We are also going to implement authentication with our ASP.NET Core Web API using JSON Web Tokens that we will generate using Keycloak. Last but not least, we are going to implement authorization, and to be more specific, role-based access control using roles and permissions. Before we dive into implementation details, I wanted to briefly discuss why I'm introducing an external identity provider instead of using the built-in authentication features available in ASP.NET Core, or maybe some of the popular solutions available in .NET like Identity Server. So what would be the benefits of using an external identity provider such as Keycloak? First of all, established identity providers have very robust security policies in place. Application security in general is a very complex topic, and there are many nuances to implementing security correctly inside of a system. And in most use cases, this is a generic concern, so it will be time and cost effective to use an existing solution that can already solve all of your problems. Other than Keycloak, which we'll be using, there are many other identity providers that you should consider, such as Azure Active Directory, which is now called Microsoft Entra ID. Then there is also Amazon Cognito and maybe specialized authentication services like Auth0, Firebase Authentication comes to mind. So there are many options to choose from, and we will be using Keycloak. Another benefit of using an external identity provider is that you will get access to a range of features that all of these services have built in. For example, you can have social logins using Gmail, Facebook, Apple accounts, GitHub accounts, and so on. And you could also easily integrate single sign-on if this is a feature that you need. And lastly, using an external identity provider can significantly reduce your development overhead. Keycloak supports the OAuth 2.0 standard, which is an industry standard protocol for authorization. We won't have time to explore OAuth 2.0 in depth, so I'm going to leave some documentation links under this video. However, I wanted to briefly mention the two authorization flows that are widely used with OAuth 2.0. The first one is the authorization code flow, where the user will first authenticate with Keycloak and be redirected to the original website. In this redirect, Keycloak will include a unique code or token that can be exchanged for a valid access token that you can use to authenticate with your application. The second authorization flow that I wanted to mention is the client credentials flow, which is more appropriate for server-to-server authentication. In our example, the backend application will exchange a client ID and client secret to obtain an access token that it can use to communicate directly with Keycloak. In the next lesson, I will show you how to configure Keycloak from scratch using a Docker container. We are going to integrate this container into our Docker Compose setup, and we will run Keycloak. I will show you how to configure a public and a confidential client and demonstrate how to create a user and then authenticate with Keycloak to obtain an access token. Welcome to the next lesson in this chapter, where I will show you how to set up the Keycloak identity provider. Here's a quick rundown of what we're going to cover in this lesson. First, we're going to set up Keycloak using a Docker container in our Docker Compose setup. Then I'm going to briefly guide you through the Keycloak user interface, and we are going to configure a public and a confidential client. Then I'm going to show you how to export and subsequently import a Keycloak realm. And I'm going to give you a quick troubleshooting guide if you run into any problems with setting up Keycloak. Let's start with a quick introduction of Keycloak. It is an open source identity and access management platform, what I like to call an identity provider, and out of the box it solves authentication and user management for us, which are the primary use cases that I will be concerned with in this lesson. But other than that, it can also offer fine-grained authorization capabilities, social media login, single sign-on, and much more. I'm going to leave a link to the Keycloak website under this video if you want to explore one of the many guides of setting up Keycloak that are available there, as well as the Keycloak documentation. And now let's get started with our implementation. And I'm going to begin from the Docker Compose YAML file in our solution. I'm going to add a code snippet that's going to configure the Keycloak container, and you can grab this code snippet from under this video, and I'm going to walk you through what we are doing here. I will be using this Keycloak image to run the latest version of Keycloak. We're going to give our container a name, and I'm passing in some startup commands that will be useful. To begin with, I'm going to comment out the import realm command, but we will get back to this a bit later. I'm also adding the start development flag, which is going to make our startup time faster because we are using Keycloak in a development environment anyway, so this only benefits us. We are passing in a few environment variables. This one configures health checks on Keycloak because I will be integrating the health check endpoint into my health check setup that we covered in the cross-cutting concerns chapter. Then I'm setting up the Keycloak administrator username and password. Another thing we'll need is a volume that's going to hold the data for Keycloak where our user information is going to live. And then this volume is going to be used later to map the Keycloak export file so that we can export our realm configuration and then reuse it if we need to. This is also going to be useful if you don't want to bother with setting up Keycloak at all. You can just take the realm export file that I will be adding to the solution, uncomment the import realm command, and then everything will be set up the same way as I will have it here in my solution. And the last thing I'm doing is exposing the internal Keycloak port on localhost 18,080. And with our container set up, let's go ahead and start our application. You can see our application is running in the background, and here is the Keycloak container that we configured in our Docker Compose setup. The internal Keycloak port of 8080 is exposed on localhost 18,080, and if we navigate to this address, we will be greeted by the Keycloak user interface. Here we can enter the admin user and password that we configured in our Docker Compose setup, and we are able to log into the Keycloak administration console. Now, out of the box, every Keycloak setup is going to come with a default realm called master. You can think of a realm as a schema inside of a database that's going to contain the users for that particular realm. Now, in our application, we have a dedicated schema in the database for each of our modules, and in Keycloak, we're going to configure a separate realm or schema that's going to contain the user information for the users of the Evently system. So let's go ahead and start by creating a new realm. I'm going to call this realm Evently, and let's go ahead and create this realm. With the realm created, make sure that you navigate it to the Evently realm, and then let's head over to the list of clients. A client represents an application that can authenticate on behalf of a user, and we are going to create two clients, a so-called public and a confidential client. A public client is an application that cannot securely store a client ID and a client secret pair. So it's only going to be allowed limited access into our Keycloak realm, whereas a confidential client is an application that can securely store a client ID and a client secret. And this is going to be our Evently backend API, and we are going to create a confidential client that we will use to interact with the Keycloak RESTful API. So let's go ahead and create our first client. I will give it the name of Evently public client. The client type is going to be an OpenID Connect client, and you can check that it should be displayed in the user interface, although this isn't critical. Let's click Next. Then we need to configure the authentication flows that we want to enable for this client. And because this is a public client, I will only use the standard flow and direct access grants. Let's click Next. We can leave most of these values empty for our use case, but in reality, this is where you would configure your redirect URIs for implementing the authorization code flow. I'm not going to input anything because we won't have a client application that's going to be doing redirects. We're going to be authenticating with Keycloak directly. So let's go ahead and click Save and create our public client. And you should be navigated to the client details screen if the client is successfully created. Now let's go ahead and create the confidential client. I'm going to say create client again, choose OpenID Connect client. I'm going to give it the name of Evently confidential client. Let's display it in the user interface and click Next. Now in this step, we are going to have some changes for our confidential client. I'm going to enable client authentication and then service account roles. This is going to allow us to authenticate with Keycloak using a client ID and secret pair, which is going to give us elevated access to the Keycloak RESTful API. Now let's go ahead and click Next. I'm not going to add anything on this screen, and I'm going to save this client. And we also created our confidential client. If you navigate to the Credentials tab for the confidential client, you will see that we are assigned a client secret value. you can take a look at this value. For example, this is the random client secret that was assigned for this client, and this is what we're going to exchange for an access token. One more thing I need to enable for this client is on the Service Account Roles tab, I'm going to assign a new role. Here, I'm going to filter by the clients and then look for users in the search filter. And the role that I want to assign to my Evently confidential client is Realm Management Manage Users. This will allow me to interact with the admin RESTful API to create users from our backend application. So let's go ahead and assign this role, and this is how we will configure our confidential client. I want to go back to the All Clients screen and take another look at the Evently public client, and you will see that here we don't have a credentials tab because we aren't assigned a client secret. Now let's create a temporary user that I'm going to use for demonstrating authentication. So I will click users and then create a new user. I'm going to say that the username is test@test.com and then the same value for the email. I will check that the email of this user is verified, and then it's important to not select anything for the required user actions. These are actions that you may require from your user on their first login. For example, updating the password, the profile, or verifying an email. So I'm going to leave this empty, and let's create our first user. And we should be sent to the user details screen. You can see that each user is assigned a unique identifier, which is a GUID, and this is how we are going to connect our Keycloak user instance with the user instance in the database of the users module. So we will have the identity ID column, which is going to point to the user identifier assigned by Keycloak. I'm also going to give this user some temporary credentials. So I will navigate to the credentials tab, click set password, and I'm going to assign a simple password of 1, 2, and 3. And let's uncheck that this is a temporary password so that we don't have to update it after the first login. I'm going to click save and then confirm that I want to save this password, and our test user should have the credentials assigned. One more thing that you may have to do before you are able to authenticate with Keycloak is set the name and the last name for the user. So I'm going to assign a test and test value for the first and last name and click save. And then let's head over into Postman, where I'm going to show you how to acquire an access token. We will need to send a post request to the token endpoint of our Keycloak instance to acquire an access token, an ID token, and a refresh token that we can use to exchange for a new access token and ID token pair. The URL that we will be sending the request to is HTTP and then localhost 18,080, which is the port that we exposed in our Docker Compose configuration. Then we have to say realms and assign the name of our realm, which is Evently, and it's unique across our Keycloak instance. Then we're going to say protocol, OpenID Connect, and token. And this is the standard path of the route based on the OAuth protocol. Then we have to specify some request parameters. We're going to send a URL encoded form, and these are the key value pairs that we have to assign. I'm going to use a grant type of password, which isn't recommended anymore, and I think it will even be deprecated in the OAuth 2.1 standard. However, it's simple to use and is going to be sufficient for our demonstration. In a real-world application, you would want to use the authorization code flow. So let's stick with the grant type of password. Then for the client ID, we're going to use our Evently public client, which only has the client ID, which is also the client's name. Then I can specify the required scopes for this request and the username and password of the user registered with Keycloak. And these are the dummy values that we just assigned when creating the test user. So let's go ahead and send this request. And you can see that we get back a response containing an access token when the access token expires, when the refresh token expires, the refresh token value, an ID token, and a few other values. Now let's start by inspecting the ID token. I will head over to jwt.io and I'm going to paste the ID token into the form here. And on the right side,